Good morning everyone, welcome to video Y3C7. In this episode I will explain everything you need for chapter 7. This chapter is one of my favorites as it is all about triangles and the special trigonometry ratios. Sit back, relax and welcome to chapter 7. This chapter is heavily related to chapter 2, so if you haven't seen that video yet, please do. We're going to start this chapter with the tangent, the first trigonometry ratio I already told you in chapter 2. When we had to calculate the angle of elevation, we used the words rise and run. But you will quickly find in this chapter that almost none of the triangles have a rise or run, as no sides are horizontally or vertically. So instead of rise and run, from now on, we are going to use the words opposite and adjacent respectively. Adjacent meaning right next to each other. That means, looking from angle A, side BC is the opposite side and side AC is the adjacent side. So, starting today, we will be calculating an angle like this. First, we write down the trigonometry ratio formula. The tangent of angle A is opposite over adjacent, meaning BC over AC. We then fill in the numbers we have, meaning the tangent of angle A is 8 divided by 14, which is approximately 0.571. Lastly, we take the inverse tangent of 0.571 to receive a 29.7 degrees for angle A. Let's do another one. This is triangle KLM and I want to know how big angles K and L are. To calculate angle K, we start with the trigonometry ratio formula we're going to use. As the opposite side of angle K is LM and the adjacent side is KM, we add that to our line. For our second line, we fill in the numbers we have. LM is 65 meters and KM is 150 meters. 65 over 150 is something we can calculate. It's roughly 0.433. We then take the inverse tangent of this number and receive an angle of 23.4 degrees. To calculate angle L, we follow the same steps. But notice that the opposite and the adjacent sides are actually swapped, as KM is now the opposite side of angle L and side LM is adjacent to angle L, meaning we now have to calculate 150 divided by 65, which is 2.307. We again use the inverse tangent and find a 66.6 degrees for our angle. Now let's use our knowledge to calculate a side when we already know the angle. Take a look at triangle PQR. We know that angle P is 14 degrees and that side PR is 10 meters. I want to know how long side QR is. We start similarly to the previous exercise, the trigonometry ratio. As we know angle P, we act from there. The tangent of angle P is opposite over adjacent, meaning QR over PR. For step 2, we fill in the numbers we know, so we receive the line, the tangent of 14 degrees is equal to QR divided by 10. To figure out what QR is, we need to multiply the tangent of 14 by 10. And 10 times the tangent of 14 degrees gives me a 2.5 meters for side QR. Another one? Of course. Triangle DEF, with EF being 16 meters and angle D being 72 degrees. We want to figure out the length of side DE. Again, we start by writing the trigonometry ratio. The tangent of angle D is opposite divided by adjacent, which in our case is EF over DE. We then fill in the numbers we know. So the tangent of 72 degrees is 16 divided by DE. But instead of multiplying the numbers, To figure out DE, we now have to divide 16 by the tangent of 72 degrees. This gives me a 5.2 meters for DE. So, sometimes you have to multiply numbers and sometimes you have to divide them. If you're having trouble figuring out what to do, you can use a little spell. Behold my magic spell, 2 is 6 divided by 3. It's a simple spell, but quite unbreakable. You see, although you might not say it in the beginning, these two exercises are actually quite similar. Both of them are divisions. But my magic exercise is much more simpler. As DE is on the bottom spot, I cover up the 3 in my magic one, as that one is also on the bottom spot. We now have a 2 and a 6 in a special exercise. And to return the 3, we need to divide 6 by 2. The same thing can then also be done with the complicated exercise. 16 divided by the tangent of 72. Understood? Then let's move on to the next paragraph. Paragraph 7.2, the sine. The second of the trigonometry siblings. So, to use the tangent, we need to use the opposite side and the adjacent side of an angle. But what if we have the opposite side and the hypotenuse? Of course, we could theoretically use Pythagoras to calculate the adjacent side and use that one in the tangent. But that takes a lot of time and we don't have that much time on a test. So, the mathematicians of old have created another function, the sine. The sine is the same as the tangent, but uses a ratio opposite over hypotenuse. So, for calculating angle B, we're going to use the sine, meaning AC over BC. The second line will then be 18 over 21, which is approximately 0.857. To get our angle, we then take the inverse sine of this number to receive a 59 degrees for angle B. Let's do that again. Triangle KLM with one side of 5 meters and a hypotenuse of 62 meters. We want to know angle L, so we make calculations from angle L. The sine of angle L is opposite over hypotenuse, so km over kl. We fill in the numbers we know, 5 divided by 62, and receive 0.080. Finally, we take the inverse sine and receive a 4.6 degrees for angle L. And of course, we can also use the sine to calculate one of the sides. This is triangle PQR. With the information I know, I want to figure out the length of side PQ. We start by writing down the trigonometry ratio. The sine of angle P is opposite over hypotenuse, which is QR over PQ. In the second line, we fill in the numbers we know. From here, I summoned my magic assistant, and with some logic, 6 divided by 2 is 3, I know that I have to divide 10 by the sine of 14 degrees to receive the correct answer, that PQ is 41.3 meters. So now you know how to use the sine in an exercise. On to the next paragraph. Paragraph 7.3, trigonometry ratios. We're not finished yet. The tangent is used in combination with the opposite side and the adjacent side. The sine is used in combination with the opposite and the hypotenuse. But what if you have the adjacent and the hypotenuse? Then, my good students, you can use the cosine. The ratio for the cosine is adjacent over hypotenuse. So, if you want to figure out angle F, you follow these steps. First, you write down the trigonometry ratio you need to use, in this case the cosine, which is adjacent over hypotenuse, meaning df over ef. We fill in the numbers we know and calculate the result. Finally, we take the inverse cosine to find a 69.2 degrees for angle F. And if you want to calculate a side, then you follow almost the exact same steps. You write down the trigonometry ratio with the correct sides. You then fill in the numbers you know, and with the use of some magic, you can figure out how long the asked side is. In this case, PQ is 15 times the cosine of 22 degrees, which is 13.9 meters. And now you know how to use the trigonometry ratios. And I know what you're thinking. I can't remember this is way too hard. And then I will say, stop complaining and remember this. SOHCAHTOA. Because if you take the first letter of each word, you get the memory aid SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And with the memory aid, all of these exercises are a walk in the park. Just write it above your test the moment you receive your paper. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Let's do one where you have to use the memory aid to your advantage. This here is triangle DEF, and I want to figure out side DF. Starting now, the questions won't tell you which of the trigonometry ratios you need to use. So it's up to you in figuring that one out. We write down the memory aid in the top right corner and start looking. As we know the hypotenuse and angle E, and we want to know side DF, which is opposite of angle E, we are going to use the sine here. We can then write down our ratio formula. The sine of angle E is opposite over hypotenuse, which is DF over DE. For our second line, we fill in the numbers we know. We then use some magic to figure out what to do next. DF is 23 times the sine of 38 degrees, which is 14.2 meters. Ready for the next paragraph? Now that you know everything about the trigonometry ratios and Pythagoras, there isn't a single exercise with triangles you can't solve. But make sure you follow these rules. First of all, start with a sketch of the situation, especially when there aren't any letters placed. And make sure you use a right angled triangle, as SOHCAHTOA and Pythagoras only work in those. Secondly, determine what you need to do. SOHCAHTOA, Pythagoras, write it down. Thirdly, solve the problem using the correct way, while writing down all immediate steps. Yes, all immediate steps. And lastly, make sure you answer the question of the exercise. Write it as a separate sentence underneath your intermediate steps. And don't forget to write down the correct unit and the correct amount of decimals. Paragraph 7.4 is actually nothing new. The book just goes on over several examples of the ratios and how you can use them in real life. And because I don't feel like doing that, I skip that part and go to the next paragraph. Paragraph 7.5. Calculating line segments and angles. This is only for the smart ones. This paragraph is a combination of everything you learned up to this point. Similarity in triangles, Pythagoras, and the trigonometry ratios. Again, nothing new, but this paragraph does help you with finding creative ways for calculating missing information. To summarize, Pythagoras works only in right-angled triangles and has nothing to do with angles. Similarity works when shapes have congruent angles, but are not used to calculate angles. Having parallel lines in your figure can be a telltale that you can use similarity to your advantage. Lastly, the trigonometry ratios can also only be used in a right-angled triangle and can be used for calculating both lines and angles. So in conclusion, look carefully at what you need to calculate and how you should work towards your goal. And instead of me just babbling on and explaining several exercises while you have to wait for me to wish you luck on your test, let's switch things around. If you want to leave and do your own thing, then good luck on your test and don't forget to bring your calculator. Bye bye! For those who want to see me do a couple of exercises to show you how I do it, stay and be amazed. Okay? Are the quitters gone? Good, then we can practice in peace. I say peace, but I will go over them pretty quickly. Here are 6 exercises from the book that I find interesting. Ready? Then here we go. For our first exercise, I've chosen this one. The objective for this exercise is to calculate the length of side AB. As there are no right angles in my picture, I can already tell you that the chance of using Pythagoras or the ratio siblings are slim. So I'm going to use a similarity table. Triangle ABC is similar to triangle ADE. So I make a table with AB and AD and BC and DE. I don't know neither AB or AD, but if I make AD equal to x, then AB is equal to x plus 6. Cross multiplying will give me this equation that I can solve using the balance method. I end up with x being equal to 4. But as I wanted to know the length of side AB, and I had set this to x plus 6, that means that AB is equal to 4 plus 6, which is 10. Next up is a more complicated picture. Two questions: the length of CQ and the size of angle S. And given is that quadrilateral ABCD is a rectangle of 5 by 6. There are several ways to solve this, but the easiest and quickest one is the similarity in triangle SBP and triangle QCP, which means I make a table with the sides that are useful, and I use cross multiplying to find out CQ, or QC in my table, is equal to 3.6. Figuring out the size of angle S is easy. Of triangle SBP, I know two sides. Looking from angle S, BS is the adjacent side and BP is the opposite side, which means we'll be using the tangent in this exercise. We fill everything in and find a gradient of 1.125. Converting this to an angle with the inverse tangent gives me an angle of 48.4 degrees. Exercise 3 in 3D. The question here is to calculate the size of angle BHG. This means we need to find the size of angle H between B and G. So if I were to make a sketch, we need to find this angle. Easy peasy. I already know the GH is equal to 6. So if I manage to find one of the other sides, I can use one of the trigonometry ratios to find the missing angle. I could go for BG as this is the easiest one to calculate, but then I'm forced to use the tangent again, so I'm going to calculate the space diagonal BH. Pythagoras in 3D is also quite easy if you practice enough, so I write down BH squared plus AD squared plus DH squared is BH squared. For our second line, we fill in the numbers we know. We then calculate our squares and add them all up. Finally, we take the square root of 49, which is exactly 7. Now that I know the hypotenuse of triangle BGH, I can use the cosine for calculating angle H. Following the mandatory steps, I receive 31 degrees for my answer. Question 4, a story exercise. This is a radio tower. Tim stands on top of a building that's 470 meters away from the tower. Using the data he gave us, we need to calculate the height of the tower. What we need to find out is how much taller the radio tower is than the building Tim is standing on. Which means that we have to make the 37.5 degrees without the part that's below Tim. So we have to make a sketch and calculate angle B using the tangent. Angle B is 3 degrees, which is equal to the angle Tim is seeing the base of the tower. Adding the 14.5 and the 73.5 without the 3 degrees means that Tim looks up by an angle of 49 degrees. Using the tangent again, we can calculate that the tower is 540.7 meters taller than Tim's building. So the radio tower is 540.7 plus 24.5, which is equal to 565.2 meters. Exercise 5, a rectangle. Our objective, calculate angle Phi3. If you take a good look at the picture, you will find no direct way in calculating this angle. But if you were to take a look at triangle TQV, we might have a chance. Every triangle contains 180 degrees. So if I were able to find angles T2 and Q1, I'm able to deduce angle V3. Angle Q1 can be calculated in triangle PQS. We use the tangent and find 11.8 degrees. For angle T2, we use the same steps. The adjacent side is half of the previous one, so we fill in a 12. This gives us a 22.6 degrees for angle T2. And then it's only a matter of subtracting our answers from 180 to receive a 145.6 degrees for angle V3. Exercise 6, the last one, a plot of land. The farmer needs to know the distance between points A and B. To do this, he used an extra point C that's located 124 meters away from point A. To find the distance between A and B, we first draw the altitude from A perpendicular to side BC. This causes us to now have two triangles we can use. Looking from angle C and using the sine, we can calculate the size of the altitude. We find that AD must be 113.3 meters long. Before we use this number anywhere else, let's first calculate how big angle B is. We use the triangle sum rule to figure out that angle B is equal to 60 degrees. Now we focus on triangle ADB, and particularly from angle B. We want to know the hypotenuse of this triangle, and we already know the opposite, meaning the sine is our go-to guy. We fill everything in and figure out that AD has a length of 130.8 meters. And that's how you solve questions using trigonometry. I hope you paid attention and good luck on your test. Bye bye!